Creating a net zero carbon emissions power sector and economy is an immense endeavor that requires a host of intricate technologies and applications, such as the CO2-Locate database developed by NETL. In planning for strategic carbon capture and storage, or CCS, there is a need for research and industry to first understand where existing wellbore infrastructure are located, as wells may pose significant opportunities for in situ use or potential threats to integrity, depending on structural characteristics such as age and depth. To provide this data and information at a national scale, NETL has published CO2-Locate on the Energy Data Exchange, EDX. Designed to support CCS site selection, risk analysis, and other key stakeholders' needs, CO2-Locate includes the start of an integrated geospatial national well dataset, representing credible and publicly available well-borne data from disparate state and federal entities. In addition, spatial summary layers were developed using proprietary well resources to help fill knowledge and data gaps for key well characteristics, including true vertical depth, age, and status. In addition to being a publicly available data resource on EDX, the spatial data driving CO2-Locate can soon be accessed and visualized through an interactive web mapping application. Future releases of the database will expand on previous capabilities to support future automatic updates, capturing changes among data and new data, ensuring that users have access to the most current information. For example, CO2-Locate can be used to identify areas with prominently old or young wells, as well as trends in the status of wells across the country. Moreover, CO2-Locate includes updated information from NETL's previously published award-winning Global Oil and Gas Infrastructure Database, which can provide additional energy infrastructure insights across the country. CO2-Locate offers an intuitive interface, enabling users to access and map U.S. wellbores and key wellbore characteristics across the U.S. Spatial patterns identified using the database can support safe CCS site selection, inform areas that pose greater leakage risk, and help ensure storage permanence. Designed to be a dynamic database, CO2-Locate will support future automatic updates, capturing changes among data from the original disparate sources. A method is currently being built using Python to support custom acquisition, processing, and integration, pulling data from the original resources and transforming and integrating them into CO2-Locate at the touch of a button. This method to automatically update the database will provide the latest wellbore information rather than an unchanging data snapshot in time. By using CO2-Locate, project managers, researchers, industry, and stakeholders can have access to a plethora of data that might reduce risk and uncertainties while saving time and helping to reduce costs, making projects feasible that might otherwise be prohibitively expensive or difficult. The development of CO2-Locate and EDX itself are examples of how the scientists and engineers at NETL are exploring avenues to address the nation's greater energy, economic, and environmental challenges to build a sustainable future for all Americans.